Hello students, let's see another important topic in organic chemistry, that is about anti-Markovnikov's rule or peroxide effect. So let's see this reaction, that is propene with HBr, that is propene is an unsymmetrical alkene. HBr addition to propene in presence of a peroxide gives 1-bromopropane. So this is an example of the reaction which follows anti-Markovnikov's rule. So actually this is opposite to Markovnikov's rule because the negative part of the adding molecule goes to the carbon contain more number of hydrogen atom. So according to anti-Markovnikov's rule, the negative part of the adding molecule should go to the carbon contain more number of hydrogen atom. So the addition reaction takes place here, and this is the adding molecule, and the negative part of this adding molecule goes to the carbon contain more number of hydrogen atom, and the hydrogen atom will attach to this carbon. So the product will be CH3, CH2, CH2Br, and that is 1-bromopropane. So this reaction takes place in presence of a peroxide. So there is peroxide. So peroxide is there, or presence of peroxide is needed in this reaction, and this reaction is also called a peroxide effect. So why it is called a peroxide effect? Because there is presence of peroxide. So presence of peroxide is needed for this reaction. So in presence of a peroxide, HBr addition to an unsymmetrical alkene follows anti-Markovnikov's rule. That is, the negative part should go to the carbon contain more number of hydrogen atom. So HBr addition to an unsymmetrical alkene follows anti-Markovnikov's rule in presence of a peroxide. So in presence of a peroxide, we will get 1-bromopropane. Actually, this is opposite to Markovnikov's rule. So this reaction is also called peroxide effect. So let's see the mechanism. Why this reaction happens like this. So according to the mechanism, we will see an example of a peroxide. Here we are taking benzoyl peroxide. So example of a peroxide is benzoyl peroxide. So which is C6H5CO twice O2. So this is an example of a peroxide which is called benzoyl peroxide. So this reaction is actually follows a free radical chain mechanism. So this is the mechanism, free radical chain mechanism. So let's see what is the mechanism. So there is benzoyl peroxide, presence of benzoyl peroxide is needed here. So C6H5CO twice O2, that is benzoyl peroxide. It can be written like this. And in the first step, there is a bond breakage and free radicals are formed here. So there will be homolysis and free radicals are formed here, 2C6H5COO. So this is the first step, and it forms 2C6H5 free radical and 2CO2. So it again forms free radicals like this, 2C6H5, that means here 2C6H5 and CO2 will be escaped, 2 CO2 molecules will be escaped. And in the second step, this C6H5 free radical reacts with HBr, that means H free radical and Br free radicals are there. So HBr is here. So in this case, this reacts with C6H5 free radical and forms C6H6. So this reacts together and C6H6 will be formed and Br free radical will be eliminated. Then in the third step, what happens to propene? So in the case of propene, again there is homolysis and formation of free radicals. So if there is a homolysis, so 2 free radicals are formed here. So 2 free radicals, 1 electron will be here, and here there is another electron. So since it is a homolysis and formation of 2 free radicals, if Br free radical will attach to this carbon, this will be the product, and Br free radical will attach to this carbon, this will be the product. So anyway, free radicals, 2 free radicals are formed here, And let's see what is the type of these two free radicals. One is, this is a secondary free radical, since this carbon attached to two other carbon. This is a primary free radical, since it attached, this carbon attached to one carbon. So this is primary, this is secondary, and we know that secondary free radical is more stable. And in the fourth step, the secondary free radical attached to or reacts with the H free radical, that is, there is H free radical and Br free radical. This reacts with this molecule and forms CH3, CH2, CH2, Br. So this hydrogen or this free radical will attach to this carbon. So this will attach to this carbon, and there will be the major product like this, and Br free radical will be eliminated, and 1-bromopropane will be the main product. And the product formation justifies this mechanism. So this will be the product, and 1-bromopropane, that is a major product in this case. So in presence of a peroxide, this type of mechanism takes place, that is called a free radical chain mechanism.